right, now we have to calculate the cost of debt. Okay, they say the debt is due for redemption at par in 4 years time. Okay, so we're going to have to use the internal rate of return to calculate the cost of debt. Okay, so we're going to make our table. Okay, all right, so here we're going to say year, narration, all right, so the discount factor, right, it's going to be at 10%, all right, because this is the interest rate on the debts, all right, this 10% bonds, right, so the discount factor rate we're going to use is 10%. We have present value. So we're going to say year zero, right here. We say market price of debt, meaning that we've paid. Okay, we've paid. And remember, the market price of the debt was 95 kwacha. Okay, 95 kwacha. Right. Then we have year 1, 2, 4. Okay, and this is the interest payment. Okay, this is what you'll be receiving after you pay for this bond, right? Interest payment. So we have to calculate the interest payment. So to calculate the interest payment, right, we're going to say interest payment after tax interest rate times the par value. And so we're going to say 10 over 100, open brackets. Remember the tax rate is 30%, so minus 0.3, all right, times the par value of the debt, right? And the par value we're given was 100. Okay, 100. Okay, so we start 1 minus 0.3, you get 0.7. 0.7 times 10, you get 7. All right, then 7 divided by 100, you get 0.07. Then 0.07 times 100, you're going to get 7 kwacha. Okay, so every year you're going to be receiving 7 kwacha. Okay, you pay for this debt, which is 95 kwacha. Every year you're going to be receiving 7 kwacha. Okay, then at the end, okay, at the end of 4 years, in our narration, we're going to say par value, okay, 100. Okay. At the end, you're also going to receive this 100 kwacha. All right. So now we have to find the discount factors at 10%. So have we got our annuity tables with us? If we do not have our annuity tables with us, all right, what we're going to do is this: 1 plus r to the power negative t, right, to the power negative t. So it's the same as saying 1 plus 10% is like 0.1, so 1 plus 0.1, right? And say this one is going to be to the power negative 0, all right, to the power negative 0, all right. We're going to get 1 here, okay. Now this 1 to 4 represents an annuity, okay, an annuity, okay, repeated payments over fixed period of time, okay. So for this one, we're going to use the annuity formula, which is 1 minus, right, 1 plus, okay, r, okay, to the power negative t, power negative t divided by r. Okay, so we're going to say 1 minus 1, okay, 1 plus 0.1 is 1.1, 1.1 to the power negative 4, okay, negative 4, okay, the power negative 4, okay, power negative 4 divided by 0.1, all right. So can we get our calculators and find that value?
Sorry, there's one thing. Why are you using a negative instead of a positive one?
We are discounting the cash flows, okay? We're discounting the cash flows. So whenever you are discounting, all right, cash flows, you're going to use the power negative t, right? Because we want to get the present value. So to get the present
value.
yes, so the present value is the discount factor times the cash flows, all right? Discount factor times cash flows, all right? But when it's the power positive t, right, there now you're trying to find future values.
All right.
Okay, so
So the answer on 1 to 4, the interest payment is 3.17.
for 3.17, oh, okay, here 3.17, okay, yes, 3.17. Are we getting different values? Okay, wonderful, right. Then for this year here, okay, we're going to use this same formula, but it's now going to be to the power negative 4, okay. Maybe let me write the values here so that when studying we are not confused where they're coming from. So what about 1.1 to the power negative 4? What do we get?
0.683.
0.683. Okay. 0.683. All right. So now we'll calculate our present values. All right. So we're going to say negative 95 times 1. get negative 95. Right? 7 times 3.17.
2.19.
Okay, 100 times 0.683, we get 68.3. Let's total up our present values. Okay, let's see if we get positive or negative so that we know how to deal with this other side. Because this part is dependent on if this present value is positive or negative.
Negative
Mm-hmm.
4.51.
All right. So since our present value is negative, all right, our discount factor here, we're going to divide it by 2. All right, we're going to divide our discount factor by 2. If this value was positive, we would have multiplied our discount factor by 2. Okay, the whole concept.
Hi, Mr. Mara.
Hello.
Sorry not to disturb you, but I just needed clarity on the par value, the one that we've used,
100.
one, the, the, the one, and then plus 0.1 close to the power negative 4. How are we getting, how are we arriving at this 0.68 on the present values table?
We multiplied it
Because I
by
don't seem to.
100.
The 0.68. How can we, how do we arrive at this figure on the present values table?
We use this formula 1 plus 0.1 to the power negative 4.
Okay. So all right. So meaning on the present values there, we can't find that figure, right? On the tables.
You will find this figure, this thing, 0.683. You will find it on the table. Just look under 10%. I don't know which year you find it in, but you will find this 0.6. These values here, all right, you will find them on the tables.
Oh, all right. Okay.
Okay, so as I was saying, when it's negative, we're going to divide the discount factor by 2, all right? Because the whole concept behind the internal rate of return is you want to find a discount factor at which the net present value is 0, right? So you're always going to get one negative present value and one positive present value, all right? You want to find a discount factor at which the net present value is 0, excuse me. So I'm going to say discount factors 5%. And so we're going to do the same thing, all right? 1 plus R. Okay, now in this case, our R is going to be 0.05. Okay, going to be 0.05 because the rate has changed. It's now 5%. All right, so you still get 1. Okay, you still get 1, 0.05. When we come to year 1 to 4, all right, we're still going to use the annuity formula, but our R changes. Our R is now 0.05. Okay, so it's going to be 1 minus 1 plus 0.05 to the power negative the power negative 4, okay, divided by 0.05. Tell me what value you get.
3.54. I don't know if it's correct. I can confirm.
3.54. Anyone to confirm? Anyone to justify, confirm? Okay, we'll go with 3.54. Go with 3.54. All right, and then we're going to say 1 plus 0.05 to the power negative 4.
0.823.
0.823, all right. 0.823. All right, so we're now going to do the same thing. We're going to multiply negative 95 times 1. We're going to get negative 95. Negative 95. All right. Then we're going to say 3.5 times 7. All right. 3.5 times 7.
4.78.
24.78. And then 100 times 0.83. It should be 82.3. 82.3. Okay, so let's total up and let's find our net present value.
12.08.
12.08, so we have a positive value, 12.08. All right, so now we'll find the cost of debt, okay? The cost of debt, all right? So we're going to use this formula, KD equals A%. Now remember, A% represents the lower rate, all right? So it's this 5% here, right? Plus, okay, plus NPV 8%. So the net present value we found with the lower rate, right? NPV 8%, right? Divided by NPV 8%, NPV 8% minus NPV B%, all right? This is the net present value found with the higher rate, right? The B% represents the higher rate, which is 10%. Okay, close brackets. Then you're going to say, you open brackets again, you're going to say B% minus A, minus A%. Then minus A%. So A%, that's 5%, plus the net present value found with the lower, it's 12.08. divided by 12.08 minus, okay, negative 4.51, okay, close brackets. Then we're going to say B percent, the higher percent, which is 10% minus 5%. All right. So
So the 8% is the positive value.
the 8% is the lower rate. This 5% represents this lower rate. Then the B percent is the higher rate, 10% here.
Okay.
Okay, so let's see what we get. So remember, order of operations, board mass, okay, or paid mass. You do 10 minus 5, you get 5%, right? Also here, do 12.08 minus negative 4.51, you get your value. Okay, then divide it by 12.08, you get this whole value, and you multiply by 5%, and you add it with 5%.
8.61.
What are we finding?
I found 8.641.
8.641. So we can round that off to 9%. Is everybody finding that?
Calculator, Ali. Accurate. Yes, I'm also confirming. I'm getting the same figure.
Those who don't tianka will be leaving you why. You'll be asking, sir, you're not admitting me in class. All right, so 9%, right? Is that the value we've got, everybody? So we found our cost of debt, 9%.